Hi guys, this is a third session for a winter seminar. In this session, we will talk about project management frameworks, particularly about three frameworks that will help you as a computer science student to collaborate and do and work together with other peers. So first, the motivation for this seminar. It's similarly to what other seminars, what the motivation was. So, first of all, the main thing is to help you how to organize your project. So, normally, when you have a project like a homework or like a lab research, many times you just do incrementally what you have to do, and you don't really divide the work that much. It just keep pushing every day. And while sometimes it works, you don't have an idea of when you're gonna finish your job. And also, if you want to collaborate with people, it might be quite harder to do it since there is no rules actually. So in my case, I came to this kind of concept by fail by having by failing in delivering projects in their time, and not only once, actually several times. So over time I read more about these project management things, and I came to know about some ways that I can help you. So once again, I'm not an expert, especially in this area. Maybe about coding in C++, Linux, I might have some expertise level. But when it comes to project management, I'm quite beginner. So I just know some frameworks that I use in daily basis. And as a user, I will just gonna tell you what it's about, but I don't have a deep knowledge about any of it. I don't even know if there is a deep knowledge about that kind of things, because as I read in some of the books, uh, those frameworks are not something that you need to follow right away. It's something that you need to tailor to what your project requires, and the size of the team, how the people are willing to engage in this cooperation level, if they are extroverted or introverted. There are many variables. So those one are like maybe templates or patterns that might sound more appropriate to this concept, that you have to somehow adapt to your personal situation. So, but the main idea it's to reduce your stress and measure what you do and work with other people efficiently. So my inspiration, it was about, so I explained my motivation, but my inspiration, it was this book. We cannot read the title well, but it's written "The Phoenix Project." It was a great book. It explained you what maybe dev ops, like a developer operations, does. And this guy that he's working in a as a software engineer in a company somewhere in the US, and so he gets promoted to a management position, and then he have to deal with many troubles. So he start by removing waste, and he basically applies many concepts that we're gonna talk shortly, and he makes the company to again be able to deliver projects on time, improve communication among the workers, and many other things. So the topics we're gonna cover in these presentations are different techniques, I mean different frameworks for project management. So all of them are related to computer science, and the first one is the typical approach, is the one that it's obvious. So it's called waterfall. You might use it for any kind of project in your life, not only computer science. And then we're gonna go to the lean software development, and then following extreme programming, and then Scrum, Kanban, and DevOps. So the order, it's more from the obvious to the less obvious, and until Kanban, it's from somehow less agile to the more agile somehow. So let's get started with waterfall. So what is waterfall? So waterfall is what we usually do when we get an assignment. So we first read the requirements, and then if you're in a project or in a company startup, you make the requirements, or you survey people and you get to know what the requirements are. It's a very important step. You don't want to end at finishing your project and then you fail to find out what the requirements are. However, it's not easy. It's normally many projects fails to find the requirements first because, well, they don't know. Even the customer, even if they got to talk with the customer doesn't even know. And in my in well in the for example, in a laboratory, if the person who makes the requirements is your professor, he doesn't really know at the moment whether those requirements are correct or not, since maybe after some research he finds out that the requirement that he sets are not what you have to do now. So it's very complicated, and it's very dangerous step because it's the first one. so but well, you get the requirement. Imagine that was easy, or I mean, you just got it, and then now you design your code. So in this step, all these software architecture, object oriented programming, diagrams, class diagrams, well, yeah, all that kind of user cases, that's where all goes there. So in university and college, you might have study about software engineering, and you already know some things about it. You know about design patterns, maybe. If you don't know, you know how more or less divide into classes, components, or whatever programming technique you're following. And well, it's important because if you have very solid design for your software, then, well, it will shorten the time, it will be easier to sell, and it's good. So once you get your design, you will move to the implementation of the design. That's what most of the people think about computer science coders, they do, right? It's you sit in your computer, and then you put your headsets, your earphones, play your music, and start to code. And well, you code a lot, make many lines, compile, and well, eventually you get you get what you want. So after you finish that implementation part, you go through the verification part, which are mostly you make some tests, you try different inputs, you show to the people, maybe you release an alpha and then a beta, and then so you want to find out whether what you have done it's satisfy the requirements, and then you want to check what you have done is actually stable somehow, and it's industry level, or if it is a laboratory, it's somehow not very buggy, and you really did what you say you're gonna do. So in the research paper, well, you are not faking anything. And then finally, after you done that part, somehow your code is your software is finished, but you have to maintain it. There's gonna be bugs, there's gonna be new features, there's gonna be many things that you need to add, and that's where maintenance part comes. So uh it looks okay, it looks obvious, it looks just fine, but there is some little problem here. If the require So as I said before, imagine the situation where your professor is telling you to do some software, and then all this process until verification, let's forget about maintenance, man. It takes maybe 8 months, and then by this time, after 8 months, you have this pretty solid piece of software which really satisfy the requirements. However, at that time, your professor, he might say, "Hey, the idea that we had about those features it's not a good idea. After the simulations, we found out that it's not good, so we need to change it." So then now you have to go back to requirements, change the requirement, change the design, implement again, and verify again. So it's not that good actually, to be honest, because it's very this model is good under the assumption that whenever you jump to one stage to the other one, nothing's gonna change. But that's not normally the case. So maybe in an assignment, actually, yeah, in assignments, maybe even hard assignments. I mean, let's say if you know about Pintos operating system, it's a very long assignment. It will take you a few months to finish it. Yeah, you have all the requirements there. There is a manual, and then in that case, then yeah, sure, go this way. But in a real world project, it's not good. I should say that in certain projects, it might be good. Like you are coding software for, I don't know, airplane, some avionics software. Then you really need some requirements to be approved by certain organization that's satisfies on a standard, and then the design. So in that sense, yeah, well, maybe you have to do like that, but in many other cases, which is like critical the software to be somehow free of any kind of bug from the first release, you don't want this one. So yeah, it's totally wrong. It's very, it's not what you should do. Forget about that idea. It's obvious, but it's not good. So yeah, as I said, the first point is what I said. It's requirement change. You need to change everything, and it will take you a lot of time and a lot of stress. You will become unsure what you are doing, and maybe you even lose interest in your project, which is a very bad thing. So, well, there is a good news. In the 21st century, uh, project management for um, software projects are a little bit different. They have some innovative ideas, and well, many of them are not from this century, are from the previous one, but they were mostly applied to manufacturing, like a Kanban or just in time or lean manufacturing. But well, from the 90s until now, they start to apply these kind of things to the software development. So let's get started with our first solution. So what if we do forget about maintenance, man? What if we do from 1 to 4 in a short time span? So if it was 8 months to deliver all the features, let's start with a very, very buggy, half-cooked version that takes 2 months to do it, and then we get until here. And maybe if there was 5 features to deliver, we only delivered 2. But after 2 months, we had this software which does those 2 features working. So what if we do like that? So we had this iteration of 2 months. So yeah, we plan, do, check, react, and then by the time that we finish that part, then we think about, hey, in the team. How did it go? We finished it in 2 months. This kind of sketch, like a very first, very buggy version. So if it's, I mean, the and then the team will say, "Oh yeah, it was good because of this one, but it was bad because something." So then they talk about and say, "Okay, so for the next iteration, we're gonna implement one more feature, or maybe two of them, and then for those two ones, we're not gonna repeat the same mistake we repeat in the previous one." So that's what lean framework it is. So the idea it's having many iterations, well, many, as much as you need, and then every iteration you incrementally improve the quality of your software. Every time you iterate, you remove waste, which means things that were not good in your team or in your development. So you always, at every iteration, at the end or at the beginning of the next iteration, you will make sure that you're not going to do the same mistakes you did in the previous one. Or if you need some new tool, if you need something, you will provide it. So the idea is that as the iteration goes by, productivity increase, and then after certain iterations, you will have your complete product. And then the other good part about this one is because you keep iterating, you don't deliver all the features at the same time. If something change in the requirements, because you keep coming back to the requirements every like 2 months in our case, it's much cheaper to have a new requirement or to change the requirement because you don't have the 8 months, you actually have the 2 months and you're halfway. So that was our first solution. It's pretty solid. Let me check the time. And it's actually really work. I mean, it's easy to implement. It's not so that's very nice. It's easy. There is not many rules. Just like that. If you search online, there will be books written about this, but those ones are the main ideas, and then you can just implement it in your team. Or if you work alone, it's also possible. Actually, it's a good thing to do. I try to do in my life. So they had this. Uh, well, I forgot the. So they had this word in Japanese word, which literally it means improvement. Actually, I learned this from my operation class and technology management class. So I forgot the Japanese word. It sounds very similar to the Korean word, but in Korea it's called keson, and keso is improvement. So they always talk. I mean, they refer to this lean manufacturing in that case. So the idea is that continuously improving. Always try to improve the process because then you will improve productivity, and then you can spend time in things that requires more intellectual skill, creative, and less time in mechanical task. And it really applies to software. You know, we are lazy people. I mean, everyone somehow it's lazy, but somehow I got to know that in the computer science world, we are a little bit more lazy, and but we are kind of in the sense that we try to be smart about it, and we try to automatize as much as we can because we know that if we automatize the process or the tools that we use, everything, which is actually the process itself, we will spend less time in the office and we will enjoy more time with our friends, family. So that's part of it. And that's something that you have to aim. You don't want to be 24, well, 12 hours a day, 6 days a week in your workplace or in your lab, struggling, repeating the same things over and over again. Your goal should be to go there every like a 4 or 3 hours per day and then do what you have to do for one day and finish it. That's amazing, but it's possible. I believe it's possible. Well, if you apply this improvement thing, Kaesong in Korean. So second solution, it adds more techniques. So the first one we had this very simple four-step diagram. Now we have, well, so now we have more steps, more stages. So, well, as you might see, there is a lot of plan. So now we don't talk about requirements. Now we're talking about release plan. So, well, first of all, this one is called Extreme Programming. It's from the 90s. I'm not very sure, but Windows XP it comes from that come from that concept. It was coded in that way, maybe. So it's kind of fun when I talk about extreme programming. The first time I tried to introduce it in my team, what they said to me was, "It sounds like the kind of programming that you go crazy and you keep coding until 6 a.m. and drinking a lot of coffee and non-stop, then finish something you have to do in 1 month within 5 days." But it's not like that at all. Actually, it's the other way around quite a lot. So it's more about this kind of smart way of programming. So as a well, as a calendar, I mean, as a schedule, it's different stage over time. We have we substitute the requirement step as a release plan. So in the release, so we have this little table, and we say, okay, by these dates, we're gonna deliver this feature. It's a roadmap, actually, simply talking. And then for every so then over time we have like a few things that we're gonna deliver every some time. So to deliver those features, we divide in iterations. Normally they are time box. What I mean, they are mostly always the same time span. So maybe like for the first release, we release every 2 months, but we have 2 weeks iterations. So we got 4 iterations overall. And then after we had this iterations plan, 4 iterations in our case, let's say, we make some documents where we say, okay, so we finish this. So we make sure that the iteration is successful if we satisfy these little requirements, which is acceptance test. Wait a second, I'll drink some tea. And then we start iteration every day. We when you go to office or if you do online chatting, whatever you need, you make sure to talk with everyone like a 50 minute, no, sorry, 5 minutes meeting or 3 minutes. It's very short, just to ask everyone, uh, how was yesterday work? There was something, uh, there was any obstacle yesterday? There was any good idea? That kind of questions you ask. It's very flexible. It doesn't. I read some books and they always say you have to be 3 questions. No, it can be. The main idea is to make sure what happened in the previous day and the plan for the current day. And then, well, so that's 1 day level, and then for every day, I mean every hour. So so let's just forget about this part right now. So extreme programming is they have many techniques and many ways of programming that they suggest and they say that we should adopt it. So first one is a unit test. So unit test, I assume you know what is it. So in this framework, before you implement a feature, you have to implement the unit test for that feature. And what I mean by feature in this case, I mean a class behavior. So there should be nearly 100% test coverage. Second part is a pair programming. They encourage a lot pair programming. So the idea is that, well, two developers. They're sitting in one desk, and then while one of them is coding, the other one is looking how he's coding. I tried this one sometime. Every sometime is good. I mean, every day, little time is fine. But I found myself going crazy if you stay for like a 4 or 5 hours with the other dude looking at your screen while you're coding, because the other guy gets bored eventually. So I encourage doing that, but maybe 15 minutes per day. So the other guy gets to know what you're doing, and he might help you with some things that he sees while you're coding. And then the other part, refactor. So I like this part because I like to refactor. So refactor is like a it's a task that doesn't implement any new feature to your code, but it just made the code inside the engine to work better and to be easier to maintain. So whenever you implement a new feature in this iteration plan, you always have to clean up the mess you have done. So this is related to the cyclomatic complexity. So you have to be careful how you write code, because otherwise, if you don't refactor enough, you might end up after certain lines, maybe 10,000, 20,000, that adding something new is so hard that sometimes it's easier to just from the beginning write a new software. And that was my case 1.5 years ago, and it was terrible. We lost, I mean, it was terrible in the sense that we lost 1 year of work just to re-implement a kind of complex, relatively big piece of software. And then user stories, we're gonna talk about this one a little bit later. Versus task. So you're not talking about features anymore. You're talking about user stories, which are kind of like a use cases. So, well, we're gonna talk later about this one. And a lot of meetings, a lot of communications overall. It doesn't have to be in person. It can be online. It can be chatting. But the main idea is to have a lot of communication. It's good. I mean, I personally like to talk a lot. Some people doesn't really like sometimes, but well, it have to be done. I think it's the right way to go. So here is some pictures. Hmm. So as it says in the charts, when you have these agile methodologies, like the first one and second one, you have this kind of graph. There's many iterations, and this is a change over time. So because you have many, as you're growing, you have lower risk. But when you using the waterfall methodology, as time goes by, if you add more changes, it's getting harder actually. So that's the idea about this graph. Let me check the time. Okay, good. 30 minutes. Next, Scrum. So Scrum, it's very popular framework, and well, it's an extension of XP and lean manufacture, but it has a very, how can I say, it adds more things. So I will say a strict time box for iterations. You have new meetings, which is called retrospective meeting, a sprint meeting, and release meeting. While in XP, you have plans. It's not doesn't have to be a meeting. I mean, it's flexible. In a Scrum, it's actually say, okay, you have to be a meeting. And then now you divide in your team different kind of people. So you wanna have one guy who is a scrum master. So his only job is to make sure that people can work well. If they have some problem, he will fix it. If they need some tool, he will get it. And he will organize the meetings, try to the people to be communicative, try to install a good environment in the workplace, whether it is online or offline, I should say. And also, you get the product owner. So, the product owner is the guy who decides which features or user stories should be implemented first, in which order. He puts priorities. So he's always trying to talk with the customer or trying to gather information about how the requirement should be. And then he prioritizes continuously. And that's his job. And then a Scrum Master should be able to enhance the communication between the development team and the product owner. And yeah, so other than that, it's very similar to XP, where you have the so while now iterations are called sprints in Scrum, but it's the same concept. So you have the sprints planning, sprint backlog. Well, so for every iterations, you have a certain user stories you want to implement. So user storage are small features. So maybe say improve the, let's say, the performance of the some websites. That's a user story. And normally they're written as an user. I would like to, when I click to this button, have this feature to happen. That's usually written like that. And then for every sprint iteration, same thing, you will have a certain user stories that you want to implement. So let me show you with an example. Mhm. So here we have a Kanban, and so we have this for my project, and then we have product backlog, and those ones are task or user stories that we have to implement. So this part, it's like a long term. We didn't decide when we want to implement it. We cannot decide it in the roadmap, but it's very loose. And then in this part, it's for this iteration, this sprint. So it works like that. The product owner, he will change the order of the task to make sure that the ones with more priority, they are on the top. And then for every iterations, we're gonna put in here which task we're gonna do for the next 2 weeks, for example. And then people will take it from there. So developers, they say, okay, I want to do this one. So they move it to the in progress pipeline, and then they assign themselves. So that's how it works. That's pretty much how the iteration sprints in Scrum. So yeah, they have many sprints, and in the sprint they decide what you're gonna do at the beginning. At the end, they talk about what happened. They have release meetings. They have the user story. They have the product owner, Scrum Master, and then that's it. But maybe maybe it's too complicated for my small projects. Maybe I'm just 2 persons or 3 persons working. We have a lot of communication. Maybe the first approach iterations, or maybe some part of XP, it was good idea. But this Scrum looks very tough. We have product owner, Scrum master. I don't even know what a Scrum master does. Someone might think. And well, so there is some alternative that might be much simpler. And yeah, I will recommend it. So one of them might be continuous integration. So let me put it this way. Imagine that this guy finishes Pierre's sequel and then he put it here. And then when he finishes, he it will go away, right? After the review. So at that time, imagine that automatically we release a version with a number that he has a feature. And then just like that, we don't have it to do. We have the product backlog. So over time, as we're finishing things, people is taking things from here and put it here, like that. And we don't have time box. We don't have iterations. It's just like that. It just goes, and then by the time that it's around here, new release, and totally new release. If you're making a website, the website gets upgraded. If you're making a Chrome extension, you push like a new one, and yeah, just like that. So we forget about iterations, we forget about everything, and not everything. Sorry, I mean we forget about these roles like a Scrum Master, project owner, and in some cases it really works well. Websites mostly. If you're making something maybe more, how can I say, more traditional, maybe not. And yeah, that's good. So another way of going, it's similarly to continuous integration, but then it just add one more thing. What it add is actually something that many people use. It's called work in progress, WIP. So it's same as the continuous integration in the sense that you don't have this to do, you just have the backlog, but you make sure you set some work on progress so your developers can now work at the same time in more than maybe two tasks here and then three tasks here and then like that. So in that sense, you make sure that all the pipelines they are working somehow. There is no bottlenecks, and it goes way beyond that. There is a whole philosophy. Well, philosophy is a very strong term, but the advice that one developer, the best that he can do is doing one thing at a time, and then trying to encourage it by putting those limits. And it's same as a continuous integration. By the time that something goes after review, it goes deploy, it goes release. And as I one tool that comes very handy, if you watch the previous seminar, you which we did cover about that, it was Travis in GitHub. Let me show you. So for the pull request, it's out of the topic in this seminar, but I already covered in the previous. So this Travis for this pull request, it runs on a script in a virtual machine somewhere. We don't need to know where is it. So the good thing about this one is that after the tests are passed, we can do something useful. In my case, I always run this conditional code. So basically, what I do is I have websites where I have all the documentation from my code. So I deploy it there, and that's what it does. But if your project was actually a website, you can just deploy in your server, your hosting server, and that's very nice thing. So I well I define it in here. It looks terrible in this. Wait. Yeah, this is the code. So that's how I define it in Travis. So you can change it to, in the case you're doing a website, you can change it for that. And then also it's possible to make a release of your project and put it in the GitHub. In just increments, I don't know, one number. And yeah, then you will achieve continuous integration in your team. And that will help you a lot because you don't have to manually make a new release and all the stuff. It just after it's merged in master, it's released. As simple as that. So so well, that's what we have talked so far. And then this is quite different, but I thought that it would be nice to introduce it because next topic is a DevOps. So it's very, how can I say? I must say that everything I cover in this winter seminar, it's somehow related to this DevOps. So I always keep repeating, automatize. It's great. It saves you time. It makes things easy. It makes your job much more interesting. And then continuous integration is a great thing. We have seen it. It's part of the automatizing, managing Git and GitHub and the other tools to ensure communication in the team. We covered before, like a Slack or ZenHub, and monitor and test the application. So in this case, it's mostly make sure that new improvement results on same performance or better, or at least measure. And also this DevOps, which is actually a real position, people work as a DevOps. They might be part time, they might be full time. They also make sure that well, they are operation people as well. So if they have deployed their software in some machines, they make sure that it's keep working and it's upgraded and there is no problem. And then as a final topic, as a final concept, which is quite important in this DevOps, I should say about infrastructure as a code. This one is a great thing, and it's very related to automatizing things. So the idea is that actually it's like as I did here. I just input these three things, and then somewhere I will create a virtual machine which actually just follow. I mean, it's a precise Ubuntu, and it's a container Docker, and then yeah, with those package and those settings. So I somehow the infrastructure of my software I can manage it with my code because this one is a code. It's not a code like uh, imperative language or something like that. Well, maybe here it is, but declarative call programming. But it's a code, and it's a great thing because I don't have to manually do it. I don't have to provide actually. I don't have to buy a new server and set up, install everything. I just like that, and this one can be applied to many other things. The unfortunately is out of the scope of this seminar. So well, this is the end of our project management frameworks. Uh, I'm not sure if I went too slow or too fast, but one more time, I'm not an expert, but I got to use those frameworks and it really helps you. And for those who are working in a laboratory, which is my case, and they are involved in somehow medium and long term projects, I will say adopt continuous integration, Kanban, and some parts from extreme programming. It's very, how can I say, it's very easy to adopt. And the idea of automatizing, removing wastes, and refactor, it's very powerful and it just makes your life in your job more exciting. Because I don't know, I'm that kind of person. I think that everyone is a kind of person who kind of enjoys making his life easier. So this is part of it, and well, also as a last note for this seminar, I will say that communication is very important. And even though it's hard, even though there might be different cultures, highly encourage you to try harder because there might be many misconceptions and many things that it might be just not have happened if you had more communication. So if you have any questions, please leave some feedback, some comments. And as I said, I'm just a student. I'm not sure about the quality of my presentations. I normally present in front of a crowd, so it's easy for me to know if they like it or normally they interrupt and then we have this conversation over and over again. These are very different formats. I'm just talking alone in the computer, but as I said before, it's part of my it's part of my requirement to graduate in my university, and I happily do it. I like it, but it's the first time I'm doing this one. So yeah, whatever good idea you have, please let me know. Thank you.